Okay, this is Miss Pal again. I wanted to go and open up this Geogebra again and look at how to use this program to do a reflection. So first thing I would do is create some kind of figure, something possibly like a convex quadrilateral. Now we're wanting to do a reflection on this shape. So to do a reflection, you have to have a mirror line. So if you want to do a reflection and you don't see the tools, hit this more. And then you can scroll down to the transform menu, and underneath that says reflect around a line. So when you click on that, it will tell you that you have to select the object and the line that you're wanting to reflect across. So I'm going to click on the inside of the object. I'm going to reflect it across the y-axis, and it gives me the reflective image on the other side of that y-axis. Again, if you're wanting to move kind of some objects around, this program only lets you move the pre-image around. And so when I move one point, it has the effect on the other side of it equally the same because it's symmetric. So that would be a reflection across the y-axis. So you can see that if it was in the second and third quadrant, the reflection will be in the first and fourth. Now, something that I wanted to talk about is when you're looking at reflections, reflections is the only transformation that reverses orientation of the points. And so to explain what I mean by that, if I read these points A, B, C, D in alphabetical order, I would be reading them counterclockwise. But if I read A prime, B prime, C prime, and so on, if I read those in alphabetical order, that would be clockwise. So you'll notice that reflection changes the orientation. If you've ever looked at how they spell ambulance, it's spelled backwards because when somebody looks in the rearview mirror, it will actually show it to them correctly because it does reverse the orientation of the letters. So I wanted to make sure y'all kind of had an understanding of what that would have meant on that one. So let's say that I start over. You can save it, don't have to, but I'm wanting to reflect it across the x-axis. Let me get it going here. Mouse. Well, you gotta click on the point. Okay, so just making a simple triangle, I can scroll down to reflect. I can click the shape and the x-axis, and then it will do a reflection over that. Now, what makes it a little bit harder is when they're wanting you to reflect it across the line y equals x. So I wanted to talk about what exactly would that line look like. So if you had the equation y equals x and you made a xy table, if I put in x to be 5, according to this rule, the y value has to equal it. So that has to be 5. If I put in 12, I have to get out 12. They match all the way up. If I have 0, I get out 0. Well, that line ends up going 0, 0, 1, 1, 2, 2, 3, 3, and the other direction. If x is negative 1, y is negative 1. So it's the diagonal line that cuts perfectly through that first and third quadrant. So if I'm wanting to reflect it over that line, then I have to go up here and I have to actually create that line. So I can create a line here and make it go through the origin and get it close on that 1, 1. That's the mirror line y equals x. So if I want to reflect it across that line y equals x, I click reflect about a line, I click the object and the diagonal line, and it flips it across. So you can kind of see it's a little bit harder when you're reflecting across that y equals x because it changes it a little bit different than what you're used to seeing. So whatever you move to this side, if B is on the left of it, B prime is going to be on the right of it, and vice versa. You can kind of make it go like that. Now, one thing you can do is reflect it across the line y equals negative x. Y equals negative x is the line that cuts perfectly through the second and fourth quadrant. And that means if I plugged in 1, and if y equals negative x, then it would negate the 1, and the y value would be negative 1. If I plug in 2, I get out negative 2. If I plugged in a negative 3 for x, and the y is the negative of that, it'd be 3. So that would be what your line would look like. So you can kind of use this GeoGebra to help you do some of those different reflections. You could also make it help you flip lines, flip across lines such as x equals 3. So if you had to create a line that is x equals 3, you go to 3 on the x-axis, and this line right here would be all the lines that's x equals 3. So if you had to flip across the line right here, you take a little, I will just do a little triangle, and hit reflect around a line. Now, if this is your mirror line, you're going to see that when you say that the mirror line is symmetric, that means everything has to be the same distance from it. So right here, C is 2 units from that mirror line, and C prime is 2 units from the mirror line. But D is only 1 unit away, and D prime's 1 unit away. So you can kind of look at it that way. So if the lines are up and down, they're really easy to count. And I'll go back and kind of show you a way you can kind of draw it by hand, doing that y equals x. So let's say that I ask you to flip it across the line y equals negative 1. This is the line y equals negative 1. It starts at negative 1, and it's got that 0 slope. So if I go back and reflect it across that, it's going to go from the top to the bottom instead of going this way, going from the left to the right. So I reflect across the line, click this and that, and then I can go through and count how many units. This is 3 above right here. So this E prime would have to be 3 below. So a lot of things with reflections is basically counting. Now, I did want to go back and talk about what would happen if you just wanted to draw that y equals x and kind of reflect it by hand in case you didn't have this program kind of do it with. I'll show you kind of an easy way of kind of counting it. Okay, so if I go back, I make the y equals x, which goes through 0 and 1, 1, and I ask it to reflect it across that line. If you did only have graph paper, here's one way you can do this. You can look at B and go down until you hit the mirror line. So it took me down 2 units, but since this is a diagonal line that you're reflecting over, you have to change directions and go 2 over. Now, you could say, well, what if I went 2 over first? If you go 2 over first, you have to change direction. Now, common sense would say you can't go up. If you went up, you're going to be on the same side of this line, so you naturally have to go down. So let's say that I'm looking at point A. You can go in either direction. You could take A and go 1, 2, 3, 4, 5, 6, 7. And if you're going 7 to the right, you got to change direction, and it only makes sense to go 7 down. And then with C, you could count down. So this C, I'm counting down 7, so I got to change direction and go over 7. So if you have graph paper and not this computer program, that's an easy way of like making a reflection on that. So good luck with this assignment.